think it's well, we can get started now. So good morning, good evening, and good afternoon, everyone around the world. So this is the fourth meeting of our SIGCOMM Paper Reading Group in this new season. I believe the 21st meeting in total. So in the goal for again for some of you who just joined the meeting, the goal for this reading group is to provide the education and the research opportunity for students to learn about latest research result, and in the meantime to learn about how to present the paper and be essentially a good teaching exercise. So in every meeting, we will select one paper, mostly from SIGCOMM and SDI, but mostly SIGCOMM. And we will invite ask a student volunteer to present the paper, hence giving him or her exercise opportunity. And after the presentation, some of our organizers will host a live discussion with some of the authors in the of the paper, together with to answer questions from the audience and also to discuss potential issues or like a future research opportunities that arise together with the paper. So we in the past 20 meetings we pretty much covered most of the aspects in networking. So you are bound to see some similar topics that we covered in previous meetings. But this week we selected this paper, an experience paper, and as well as a verification paper, which it was published in SIGCOMM 25 in Portugal 2 months ago. And the title is New Evolution of Hoyan, Enhancing Scalability, Usability, and Accuracy for Alibaba's GlobalWAN verification. And for some of us, we probably know that Ali has been very successful in applying formal methods to verify and to help automate the operations of their GlobalWAN infrastructures. And we, in the past few years, we and NSDI, we've seen many of the latest progress along the design and evolution of Hoyan. So I believe this paper tried to summarize some of the past experiences and also try to highlight some new research opportunities for this paper. And for this paper, for this week we invited Feng, who is a senior PhD student at Xiamen University, to present this paper. And in the meantime, we are honored to invite Nan, Yifei, Mengqi, and Yuyang, 4 of the primary authors of this paper, to join us for the discussion. And so I think without further ado, Xing, you can start your presentation. Thank you.
Yeah, okay. Thanks for the introduction. Hello everyone. I'm Xing Feng from Xiamen University, advised by Professor Zhang. Also, I'm a research intern at Alibaba Cloud, where I've been fortunate to participate in the Hoyan project, a production network verification system deployed in Alibaba Global Wide Area Network. Today, I'm honored to introduce the SIGCOMM 25 paper about Hoyan, which shares Alibaba Cloud experience in evolving Hoyan to enhance its scalability, usability, and accuracy. As one of the biggest cloud service providers, Alibaba Cloud operates a global wide area network serving billions of customers. By the end of 2024, this one interconnects tens of data centers, including over 2,000 routers, and carries millions of IP prefixes, ensuring the availability and the reliability of such a massive network is extremely important. However, to operate such a hyperscale network is very difficult. One of the biggest challenges lies in the correctly configuring the network according to operators' high-level intents, especially during the configuration updates. According to the statistics collected a few years ago, 56% of the network incidents were caused by configuration update, making it the leading root cause of failures in Alibaba WAN's operations. To ensure the configuration correctness, Alibaba Cloud started the Hoyan project back back in 2017. At a high level, Hoyan performs the route simulation to predict the routing tables of the updated network. And it has three inputs. The first is the current network snapshot, including network topology and configurations. And the second is the configuration commands for the network change. And the third is the external routes that are injected into the network. Then Hoyan checks whether the simulated routing tables satisfy the operator's high-level intents. And in its early stage, Hoyan mainly focused on reachability verification. For example, checking whether routes from router A can reach router B and support control plane protocols such as BGP and the IGP. And between 2020 and 2022, Hoyan was gradually enhanced with traffic simulation and verification capabilities, as traffic node-related incidents had become one of the major causes of the network failures. Given the input traffic flows and the simulated routing table, Hoyan simulates the forwarding behavior, forwarding paths of these flows, and computed the traffic load on each network link. Then it verifies whether the resulting forwarding behavior and the link utilization after the change meet the intended properties. During this period, Huyan was also extended to support additional control plane protocols, including policy-based routing and segment routing on top of BGP and IGP. And previously, Huyan mainly focused on verifying the network state after the change. In 2023, to support the specification and verification of properties between the networks before and after the change, the team introduced a new specification language called RELA. RELA allows operators to formally describe intents over the network changes, such as flows originally on path A should be moved to path B. Hoyan's evolution did not stop there. Its development has been driven by two major forces. The first is the rapid evolution of Alibaba's cloud material network. Starting in 2023, the network began deploying a new generation of whatever network, which not only expanded the number of routers, but also introduced new features such as SRv6. The second is ever-increasing operational demand. The operations team continuously raised the bar for Hoyan, demanding broader prefix coverage and support more diverse types of network changes. So, as a result, Hoyan started to face new challenges in scalability, usability, and accuracy. For the scalability challenge, first, since the launch of Hoyan, the size of Alibaba Cloud One has grown more than 3 times, mainly due to the deployment of the next generation one in recent years. Looking ahead, the operation teams expect Hoyan to also support data center networks in addition to the whatever network, which would lead to another order of magnitude increase in network scale. Second, the number of prefixes to be verified has increased by 2 orders of magnitude. The original Huyan handled only tens of thousands of high-priority prefixes, but it now needs to simulate all prefixes across the WAN, at a scale of millions. Third, with the introduction of traffic simulation, Hoyan now has to simulate billions of flows, and it should be efficient across the entire network. However, the required simulation time for Hoyan has dropped significantly from hours to just minutes in order to support urgent change verification requests. As a result, the original architecture of Hoyan could no longer handle such a large-scale network. This figure illustrates the route simulation time of the original system, which ran the entire simulation on a single machine. As shown by the blue line, simulating all prefixes on the wide area network took more than 13 minutes. And when data center networks were included, Hoyan could not even complete the simulation for 40% of the prefixes, clearly demonstrating its limitation for future expansion. To improve the scalability, the most straightforward approach is to adopt a distributed architecture. So instead of running the entire simulation on a single machine, Huyan can distribute the workload across multiple machines to complete one simulation task collaboratively. For example, consider this simple network. To generate the routing tables for all routers, Huyan needs to simulate 6 input routes belonging to 5 prefixes. Here, the figure shows an example of the generated routing table for route A. Since the routing simulation operates on a prefix basis, the overall simulation task can be divided into multiple subtasks at the prefix level. For example, one subtask can simulate the routes for prefixes 10/8 and 40/24 on one machine, and while another subtask handles the remaining prefixes on a different machine. Each subtask produces a partial routing table for route A as shown in this figure. Finally, all simulation results can be uploaded to the cloud storage for aggregation and future analysis. Once the routing tables are generated, flow level simulation can be performed in a similar way. Suppose there are 6 flows to be simulated. These flows also can be divided into 2 subtasks, with each subtask simulate 3 flows and computing the traffic load of each link for its assigned flows. And the total traffic load is then obtained by aggregating the results from all subtasks. This approach seems very promising. However, it comes with a major limitation. Each subtask still needs to know the entire routing table for the simulation. Considering that there are millions of prefixes and thousands of routers, loading all routing tables on a single machine introduces a significant overhead. And if we look closer, each subtask in the traffic simulation only needs to load the routes it actually depends on. For example, to simulate the flow 20.1, the subtask only requires the route for 20/8 produced by the first route simulation task. Similarly, to simulate the flow 10.1, it only needs to list the route for 10/8 from the second route simulation task. And the key question is that how to divide the subtasks so that these dependencies can be minimized. So to address this, the team adopted a simple heuristic. Routes and the flows are split following the same order, ensuring that each subtask can reuse the routing results it depends on with minimal overlap. Here is the example. First, the prefixes are sorted from the smallest to the largest based on their last IP address, and then divided into subtasks following this order. For example, the first route simulation subtask handles prefix 10/8 and 11/8, while the second subtask processes the remaining prefixes. For traffic simulation, the input flows are also sorted in the same way from the smallest to the largest. Thus, the first traffic simulation subtask then simulates flow 10.1, 20.1, and 20.2, and then the second subtask handles the remaining flows. With this heuristic, the first traffic simulation subtask now depends only on the first route simulation task, meaning that it only needs to load the routes produced by the first subtask, significantly reducing the redundant data loading. The distributed simulation was evaluated on Alibaba Cloud's wide area network, as shown by the blue line in the left figure, using 10 machines achieves 5 times speed up compared with running on a single machine for the one scenario. When data center networks are included, the system can still complete the simulation within 25 minutes, demonstrating its future-proof scalability. And for the traffic simulation, the distributed design achieves 4 times speed up, and the splitting heuristic is also very effective. Without it, the simulation time increased by 52%, and as shown by the red line. And the second challenge is usability. The table lists 12 types of network changes that Hoyan needs to support, including OS maintenance, configuration updates, network deployment, and business-driven changes. As shown in the third column, the intents behind these changes vary a lot. Some only check the routes stay unchanged after the change, while others involving modifying the router attributes, moving flows, or adjusting paths after adding new routers warnings. By analyzing the network changes over the past years, these diverse intents can be broadly classified into 3 categories. And the first 2, flow path change intents and traffic node change intents, can already be handled by existing techniques such as radar and simple traffic node range checking. However, in the original Huyan, each verification item for route change intents still had to be manually hard-coded, making the process inefficient and difficult to maintain. To overcome the limitations of the manually hard-coded verification, a specification language called RCL was introduced. RCL allows operators to formally specify the route change intents and have them automatically verified based on the routing tables before and after the change. Compared with the hard-coded approach, RCL makes verification easier to maintain and reuse, as the intents are expressed in a high-level declarative and consistent way rather than embedded in code. The design goals of RCL focus on, first, it should be easy to use, instead of general-purpose query language such as SIGCOMM. Second, it should support most common route change intents that are encountered in daily operations. To illustrate how RCL works, consider a typical route change intent composed of 2 sub-intents. The first is that routes with prefix 10/24 should have local preference 300 after the change. Second, routes with the other prefixes should remain unchanged. To let the operators specify intents naturally, RCL is built on top of a global RIB abstraction. A global RIB can be viewed as a single logical table that aggregates all routes in the network, with 2 key fields, device and verb, indicating where each route resides. As shown here, the figure represents the global RIBs before and after the change, referred to by the keywords pre and post. Based on this abstraction, RCL defines a set of operations to systematically compare these 2 tables and evaluate whether the specified intents hold. Let's walk through how RCL expresses the first sub-intent. We start from the after change RIB, which is the post. First, we use the dist-vals local preferences, the expressions, to get all distinct local preference values from that table. Then we check that this set only contains 300, meaning that every route now has the correct preference. Finally, we limit the check to routes with the prefix 10/24. So the condition applies only to the intended routes. In short, the RCL statement precisely expresses after the change, all routes for 10/24 must have local preference 300. To specify the second sub-intent, the expression is even simpler. To indicate the routes remain unchanged, the specification can be easily written as pre equals to post. where pre refers to the before change rate and post refers to the after change rate. Then, because obtaining full routing tables from the live network is very difficult, the comparison between the route tables is done on selected prefixes. In contrast, traffic loads can be easily collected, so they can be fully compared across ones. Let's look at a simple example to illustrate how the accuracy diagnosis framework to identify and fix an accuracy issue. The first step is to identify links with large difference between the simulated and real traffic. For instance, Hoyan simulated 100 gigabytes on the link from A to B during the peak hour, while the live monitoring shows 200 gigabytes. Such a difference indicates that a potential inconsistency, either in the simulated routing state or forwarding behavior of the network. After identifying the link with the large traffic difference, the next step is to find a high volume flow that traverses this link and reconstruct its forwarding path. For example, here we have a flow carrying 50 gigabyte traffic during the peak hour toward the destination 10.1. And by tracing this flow, we can observe that in the simulation, it is forwarded evenly through the link A to B and A to C, while in the live network, it's only sent to A to B. This difference indicates that this inconsistency likely originates from the router A. To further confirm the root cause, the forwarding table of the router A is checked. In the simulation, router A has two ECMP routes to the destination 10/8, one via the router A and router B and via router C. While in the live network, it only uses the route to the router B. This difference explains why the simulated traffic was evenly split, but the real traffic was not. To understand the underlying cause of the forwarding inconsistencies, network experts are involved to analyze the RIPs and the configurations of routers with different behaviors. As shown here, the simulated and the real RIPs of the router A have mismatched in the IGP cost. In the simulation, both next hops B and C have a cost of 10, where in the real network, the cost to B is actually 0. The configuration also confirms that the intended IGP cost should be 10. So, why the IGP cost to router B is 0? The further investigation shows that the router A has an SR policy for traffic destination to router B. The SR policy triggers a vendor-specific behavior. The router automatically sets the IGP cost to 0 for SR-enabled destinations, making A preferred SR path to router B rather than performing ECMP as expected. This behavior does not exist on other vendors' devices, so it is identified as a vendor-specific behavior, or VSB. Once this was confirmed, the simulator was patched to correctly reproduce such cases. Using such an approach, we are able to uncover a wide range of real-world issues, and the most common ones are missing routes and inconsistent topologies, usually caused by incomplete input data. Others, configuration path bugs and implementation issues, can be patched, and the vendor-specific behaviors come from device difference and need case-by-case handling. For non-deterministic convergence, it is a fundamental issue in BGP protocol itself, which is that one configuration may lead to multiple stable states, which require more fundamental solutions. Now, let's look at Huyan's deployment experience in production. With all these evolutions, Huyan now handles tens to hundreds of verification requests each week, both manually and automatically triggered. Each year, it detects and prevents dozens of risk changes, some of which could have caused severe incidents. The table summarizes the root causes of war risk identified in 2024, and 2 representative cases are analyzed in detail in the paper. Finally, I'd like to briefly share the future directions of Hoyan. The first is misconfiguration localization. Identifying the root cause of the intent violation still needs manual effort, and automating this will greatly speed up troubleshooting. The second is intent specification correctness. Even with our intent language and high-level intent language RCL, operators may miss key conditions. Heuristics and large language models could help ensure the completeness and accuracy. The third is accuracy testing. Hoyan's reliability depends on accurate simulation, and an automated framework comparing it with window behavior can further enhance the precision. So to conclude, in recent years, Huyan faces emerging challenges on scalability, usability, and accuracy, driven by rapid evolution of our wide area network and ever-increasing operational requirements. As a response, Huyan uses distributed simulation, RCL root change specification language, and accuracy diagnosis framework to address those challenges. Hoyan is used in Alibaba on a daily basis, preventing tens of network incidents each year, helping reduce the misconfiguration caused network incidents from 56 to 5%. That's all. Thank you very much for listening.
Thanks, Xing, for the presentation. I think it's a very clean and it's a very nice organization. So now we will move on to the discussion part. So I think for this week, Dr. Li Zhao Yu, assistant professor in our university, will host the discussion. Li Zhao, you want to get started?
Okay. Thanks for Professor Xiang's introduction. Okay. I'm an assistant professor at Xiaobin University, and I'm also working on network verification for a long time, together with Professor Xiang. Okay, so let's get started. So I think the audience can either turn on your microphone to ask questions directly or type your questions in the chat box. I will have relay the questions in the chat box for you. So any questions from the audience?
To help open the discussion, I actually typed a question during the presentation. So if you guys design this RCL language, so just out of curious, what's the completeness of this this language or the expressiveness? For example, can it help describe like a root symmetry? Like even from A to B and from P to A, the root must be symmetric or must be asymmetric or must be like a link disjointed. Can RCL currently express such intents?
Yeah. So first of all, for completeness or expressiveness, actually that's not a major focus of this language. So yeah. So when we design this language, I think the major challenge we face is how to design a usable language for the operators that they can really use. We first tried more expressive languages such as SQL or like Python script, but turns out it's not a good design for them because oftentimes they have to write a lot of code, and they may not have the expertise in writing good code. So we decided to maybe sacrifice the expressiveness but improve the usability. So that's why we designed a simpler version of. You can view this as a simpler version of SQL, but it turns out it's easier for them to use. So I think that's a major consideration between the expressiveness and usability when we design this language. For row symmetry, so first of all, this language is mainly designed for control plane. So for row symmetry, if you are talking about like the example you said, you have to consider the links. the language is not used for that. But we have another language called Rela, which is for data plane specifications. That may be help. Yeah, but in general, if you ask, for instance, if a rotor A on a rotor X, the next hop of that rotor is pointing to a rotor B, and you want to say there exists another road on rotor B that point back, that may be possible to be specified in this language.
I see. So,
Yeah.
like what is like the learning curve for this for this RCL language?
Yeah. So
Mhm.
yeah, I can share the story. So basically, we did a one-time tutorial, which may be like 14 minutes, that covers everything of this language, and then they gradually can write simple specifications for like, for instance, like if they just want to replace a rotor, then the intent is simple. They write the intent that specifying no rows should change. And for other changes, we do have a developer helping them to write correct intents. But according to our observation, for them to learn this language is not really that hard, which is super surprising to me, to be honest. Yeah.
So, like, do your just out of curiosity, like, do your
Yes.
operators like complain about having to using such a maybe sounds a little bit a little bit out of their like a comfort zone to use this language? Do they have any complaints about that, or
Yeah.
because I think like network operators and also our like more like research engineers and engineers, we often tend to think very slightly different, right? So
Yes.
something we feel like very elegant, very natural, they may think, what the heck is that, right? So
Yes.
so any complaints?
I think it really depends on how much benefit you can offer while the whatever tool you develop. So I can give you one observation we made in the past half a year. Before this language, we were able to support tens of verification for major changes every month. The major bottleneck was that meaning our developers have to manually encode their intent and write the Java code for the verification logic. And now with this language, we can support hundreds of verification requests each month, which is one order of magnitude increase. And one reason for that increase is this language. Our developers do not need to write a complex and error-prone Java code. They can just help the operators directly write their intent in this language, which is piece of code, just a little piece of code. So, yeah. But for specific complaints, sometimes they cannot specify their very complex intents. That happens. When that happens, we have to force back to the old approach where we have to manually encode their intents and the verification logic in the backend within Java. That happens sometimes, but not very often.
So by in your last sentence, so when the operators give some relatively more complex intents, and they feel like they cannot express them such intents in using RCL. Have you look? Of course, just for operation's sake, you can always fall back to writing the Java code to do that.
Yes.
But you must do some post-mortem analysis, like is it because RCL is incomplete, or basically impossible to express such intents, or it's just to take some tuning to eventually RCL can still express such, but it's just in a more complex way. So what's the root?
Right, but both cases happen. For instance, like we do not have variables definitions in this language. So if you want to reuse the definition, you have to repeat that definition multiple times because we do not have variables. That is designed for purpose, right? So yeah. So for complex intents, such cases may happen, and the language I would not. So we didn't study the completeness question so far. So, but I'm skeptical about the completeness of this language. So there are cases that the language cannot specify. So both cases happen.
I see.
Yeah.
So have you considered? So sorry, I have been holding the microphone too long, but just really intrigues me. So does when operators try to use RCL, do they ask like your Tianwen large language model to help with them, or
yeah, so that's very interesting. So at the very beginning,
I also have the question.
Yeah, at the very beginning, we thought this is a new language. It must be very hard to be learned by the operators. So we designed AI tools to help them just input the natural language, and then we use AI models to generate the intents in this language. But it turns out they are super good to learn the language. So eventually, the AI model is no one uses it. That's another very surprising thing to me.
Yeah, Alibaba does hire very good engineer and operators, I guess. Yeah, but still, I think maybe just maybe to end my lines of question regarding RCL, but just maybe natural expressing intents using natural language and have like a LLM based tool to help translate them directly either to RCL and then to more details in specifications, or directly to specifications. Might be some interesting problem to work on. Just my 2 cents.
Yeah, I agree. Yeah.
Cool. Yeah, sorry. This I think that this concludes my part of my question regarding RCL. Li Zhao, you were saying?
Okay.
Maybe,
I just want to follow up. So, if it is a future direction, I want to see. So, what's the key challenge here to use the LM tools?
Yeah. I do not have enough expertise, I guess, to answer that question.
Okay.
Yeah, but I can see that there are many works in the PL domain, PL plus AI domain that uses LLM to generate test cases, to generate specifications. I think we can also benefit from all those related works in that domain. Yeah, that's my guess.
Okay.
Yeah.
So, any other questions from the audience? Okay, then let me ask a question here. So I noticed that Hoyan is focusing on large-scale WAN network.
Yes.
And I know that there are some works on verifying data center network. Yeah. So do you think what's the difference between WANs and the data center networks?
Yeah, so in our experience, I cannot speak for other cloud providers, but for us, data center network seems to be simpler than the wide area network, mainly because of before you build a data center, you have to very well designed, the architecture, the routing protocols, and everything, and then you just repeat, you just reproduce such design to multiple data center locations, right? But for one, it's kind of different. Very much, in many cases, the one is like growing. It's not designed as elegant as data centers. So sometimes you have to, you have to like have a new location in somewhere in the world. So you have to change the topology, the architecture, which is not well designed before that happened. So the architecture and the policies, the configurations in our experience is much more complex than the data centers. So in other words, it is more likely to have network incidents on the one, and it is more important if we have a network incidents on the one than in a single data center. So that is why we focus on the wide area network instead of the data centers. One reason.
Okay.
Yeah.
I see.
Yeah.
So as far as I know, different companies have different situations. For example, in Huawei, their data center networks have different generations, and then they are mixed together. So okay, in that case, that may be different because their situation is more complex. Okay.
Yes.
Okay.
So if in your past experience, have you in Alice GlobalWAN, have you experienced any like routing stability issues?
Stability?
Yeah,
Routing.
convergence issues.
Yeah.
For example, when you update your the dispute wheels, right? So when you finish updating some routers, your network enter into like a constant oscillation state.
Yes. Yeah, that's a very good question. Yeah, we do have occasionally happen that unstable convergence issues. When that happens, that often is considered to be a very severe incident. Because when we design a network, we actually do not, we want to design network in a deterministic way, but sometimes it's really hard to reason about the stability. The uncertain convergence problem happened even though you design the network with the confidence that it will converge to a stable state. Sometimes when a device fail and it restarts, it may introduce unstable convergence. So yeah, that really happens, and it's a very interesting problem to me to be solved, and it will be really helpful.
So have you tried, because like I understand, because network sometimes can be very dynamic and volatile, right? So anything can happen, right? But just even assume without considering like link failure or node failure, just the regular scenarios. Have you looked into whether you can just applying like something like a dispute wheel to verify convergence? Have you tried that, or you think that's just too doesn't scale at all? So eventually you think that's not a good idea?
Actually, we have an ongoing project analyzing the convergence problem. Hopefully, it will be published soon.
Okay, I see. Yeah, let's we'll try. We'll keep the lead on for a while. We'll see. Yeah, because like convergence issues, like in earlier analysis of like interdomain routing and BGP, convergence is a big issue there, right?
Yes.
But like at least based on from what I read from SIGCOMM analysis before, like verifying convergence might be I don't think I read such a paper before
Yes.
along the line of network verification, right? So maybe some will be very interesting. I look forward to see you guys work.
Actually, yeah, in this Hoyan paper, we have a summary of all the root causes of the identified issues. Yeah, so you can see there's about I believe the number is 1.92% of of the issues were caused by non-deterministic convergence.
Right.
Yeah.
I see. Yeah. Okay. Good. Yeah. Well, I think I talked earlier about slightly about this, but we can talk that offline
Sure.
later. Yeah. But I think that there's a question from the audience. Li Zhao?
Yes. Yeah. A question from Zhang Yongheng. Okay. He asked, do you think that if a tool can further explain why a certain configuration field or line satisfies the verified network specification, when the verification succeeds, such work will have practical value?
Okay, so as far as I understand, the question is about if we can analyze what configuration is the root cause for the intent violation, would that be a good work or not, right? I think, yeah, is that the question?
You can follow. I think he also asked when verification succeeds, focus on the success case.
Okay, so when the verification succeeds, it means the configuration is correct. In that case, in practice, the operators may not care so much about the configuration itself because it's correct. As long as it satisfy the high-level format format requirement, such as you have this like you have 4 DB spaces, for instance. Yeah, as far as the configuration is correct and is obeying the format requirement, I think that's fine. Yeah.
So what about the violation case?
Yeah. So when the intent is violated, how to analyze what is the root cause for that violation is super important. I think that's a very interesting question, and we are trying to following the line to once we identify the violation, we want to help the operator to quickly identify the configuration that is the root cause for the violation. So one such use case for this technique is for urgent change verifications, because when the change really happened, you really have a very limited time to fix that change problem. So that is, I think it would be very practical and useful.
So I also think it's an important questions. So yeah, I think
Roland, you have any comments on that? You have been working on you actually have been working on this for a while, right? Hello?
Yeah. We've been working. I'm working on configuration error localization the past 2 years. We try to use a symbolic execution, which is we symbolize some part of the configuration parameters to simulate the symbolic configuration to find which concrete parameters lead to the correct data plan to find the error. But
Okay.
there are also some, we've noticed some we use formal methods. We follow formal methods to find the error, but we do believe there are some other methods which can leverage maybe the data-driven methods, maybe LLM, to find the error, but not that correct, but which may be more efficient. I want to know how do you think those methods maybe a more formal and formal but not that efficient. The other is more efficient but not that correct.
Yeah, I think both approaches are very promising. For like the formal approach, it's rigorous and it may take some time, but given the correctness guarantee, it is very suitable for cases such as if you have a plan change that will happen in weeks, right? You have the time to run your rigorous analysis beforehand. For machine learning kind of technique, it's I would view the machine learning based technique as a assistant to the manual efforts. Such approach is efficient, and it may have some errors, but you can still provide useful information to the operators and help them to identify the misconfiguration. It will be very, I guess it will be suitable for urgent change analysis requests.
Yeah, I'm still curious. Even if we use a really formal way to automatically find the error configuration, is there still need? I mean, the operator can really ensure the tool is good and no need to check the configuration again or do the validation. I mean, even if there is such a tool, we'll use it very we will really make sure it will work correctly.
Yeah, I would say it's really hard to replace the role of network operators using a tool or a bunch of tools, at least in the near future. What we can do is to help them respond quickly and more reliably to solve network incidents. That's my view. They may be wrong, but I would say, yeah, the role of network operators is not that easy to be replaced.
And thank you, Yifei.
Sure.
Okay, I see more questions in the chat box. So, Li Yuhang asks, they usually conduct language model training in data centers. Is it possible to conduct joint training across multiple data centers in the future? In the future, could Alibaba Wang potentially handle AI training traffic flow? Has Hoyan considered this issue?
Okay, I guess this is totally out of the scope of Hoyan. Hoyan is mainly on verifying the configurations of the network. We do not consider like training or course region training. We do not consider anything like that.
Sorry. Yeah, go ahead. Sorry.
Okay. I noticed that Hoyan also do some traffic simulation.
Yes.
So, I think in AI training, the traffic flow, the pattern, is important. So, do you think can Hoyan try to verify the traffic flow and to support the AI training?
Yeah, we do have some traffic verification capabilities built in Hoyan. For instance, we can verify given a specific traffic demand, we can verify will this demand cause link overload on the network. If that such a capability, if that is helpful for AI training, that'd be great. But I'm not sure if that's if that answers the question, though. Yeah.
Okay. I think it deserves to study if AI training is an important issue or it can cause some problems in AI training. So maybe it's worthwhile to study this problem.
Okay. Thanks.
Okay. So Professor Xiang, what's your question? Okay, so maybe he's busy. So another question from the, okay.
Yeah, so sorry, I
Go
muted
ahead.
myself. I was saying just I was making similar comments because I think because Hoyan has this built-in capability to verify traffic load and trying to but in the scenario of like inter data center AI training or even inference, the traffic load may have different characteristics, which I'm just totally thinking on top of my head, but this put a specific traffic property or traffic characteristics could introduce new opportunities to accelerate traffic simulation, right? I think essentially running faster. I think that could be some research or industrial efforts to look into. I think that's my
I see. Yes. Yeah.
And I think we are really running out of time, but I think we have one more question from the audience, and I do want to take advantage of me as the organizer to ask the final question. I think that the final question from the audience is Mengqi, who is I think also one of my students. She's curious whether like in the distributed simulation part of in this presentation, whether each device needs to maintain like a complete copy of the network topology, and would this, if so, would this introduce additional overhead, and is there a way to help optimize it?
Each device meaning a server running the task. Device is not a router, right?
I think that I would say the server. Yeah, I would say
the server. Yeah. So according to our experience, keeping the network topology is fine. It's not a big deal comparing to, for instance, other information like the routing table. That is really killing us. That's a major overhead, not the network topology. So you can distribute, you can split the network topology, and each device maintain a slice of the network. But I would doubt how much benefit you can get from that. Yeah.
Okay, so let me take the final 2 minutes to ask a relatively non-technical question, because if we have known each other maybe for 7-8 years, a long time, and also Mengqi and Yuyang, we spend time in New Haven for a long time, but like I know like Yifei, you work in networking during PhD, right? But Mengqi and Yuyang and even Annan, they more focus on like PL and formal verification, right? So clearly, network verification is I think what Jennifer says, interdisciplinary area, right? Intersection between PL and networking. So sometimes for either side of the students, newcomers, new students in network PhD or PL PhD or software engineering PhDs, working in an intersected area could be a little bit daunting because they think I don't understand the other area. So speaking from you guys' own experience, what's it like? Any lessons or experience you guys care to share with the students so that they can try to pick up their learning curve a little bit faster? What do you think?
I think first of all, it's really important to know if you're working on two areas, it's important to know the knowledge in both domains. That really makes you the expert in the interdiscipline research domain. So I would say, first of all, that is important. So you have to learn stuff, and how to quickly learn such stuff. My experience is maybe it's easier to talk to people. You want to talk to like experts in each domain and learn from them. maybe Mengqi and Yuyang may have other opinions.
Mengqi, what do you think?
Yeah,
I know you are a PL person.
yeah. Thank you for your question. This is actually very interesting because in my experience, so I came from a formal methods and operating system background, but since joining the network research team, I have been working on verifying like programmable data planes or DNS software or routing software. So in my experience, I think there are a couple of things that will benefit you. So one is be open-minded, because a new domain actually means more opportunities. So if you only look at the general principle of formal methods, maybe they have been staying the same for quite a long time, maybe decades. But if you try to apply them to concrete domains, you will see new challenges, and there will be many opportunities that you can work on. And the second thing may be just like Yifei said, so how to make your learning curve or learning experience more like enjoyable. So my experience is talk to people and work with them on the real code. So that's the biggest way to pick up a new thing.
Yeah, I think I hope the students who are in the meeting can learn from Mengqi and Yifei's experience. I think that they're like a first-hand experience, right? So might be very helpful. Yeah, I think speaking from my personal experience, I do benefit a lot from talking and working with Ruizhen, because I was a pure networking guy, and I only started to work in this intersecting area like maybe 4 or 5 years ago. So it's also a exciting and wonderful experience for me. It's both Ruizhen and her boyfriend has been very helpful for me. They show me all kinds of these cool theory and tools formal methods can do, and I'm just picking, hey, which one suits my needs better to solve some problem. I think that's a very fun working experience. Yeah. So I think unfortunately we are already 4 or 5 minutes over our original time. So any last word or final comments from our guest of honor, from Xing, from other audience? And if not, and for students who are here, if you're interested in working in this area, you can drop an email to Yifei or Mengqi to apply for some research interns. And but bear in mind, they do hire the best network operators, right? So full-time jobs, I believe, is also on the table. So by all means, reach out to them. And if any questions, also you can reach out to them. Or if any suggestion regarding our paper reading group, you can contact me or Li Zhao or other students in my group. And so I think with this, we conclude our today's meeting, and we want to thank Xing for the presentation. We want to thank Yifei and Mengqi and Yuyang to join the discussion. I think it really highlights answers a lot of questions from me, from the audience, and many exciting future research opportunities. And to others out of the audience, thank you for staying late or staying around noon for your to close to your lunchtime. And I hope to see many of you next week. In 2 weeks. Sorry, in 2 weeks. Yeah. Thank you, everyone. Thank you, Yifei. Bye.
Thanks.